Good afternoon, everyone, and welcome to this new episode of Loops, organized by Velta. The title of today's episode is Advanced Tracking Technologies for Critical Raw Material Recovery. And in this episode, we are going to view the solutions developed by three different projects, Even Closer on one side and two Horizon projects, Apollo and Return from the other side. The objective of this episode is double. From one side, we want to show the European citizens what is happening within European projects. But for the other side, as usually, we are looking for synergies, for points of contact between European projects that can further develop into potential synergies and actions to not replicate budget expenditures, but perhaps to make more efficient use of the European budget we project have. So without further ado, I will call for a quick introduction and for an institutional opening, Mr. Sotirios Kannelopoulos from DG Environment. Welcome, Sotirios.
Hi, Luca. Thanks. Thank you for the invitation. I'm indeed coming from the Directorate General for Environment of the European Commission. My name is Sotirios Kannelopoulos. I work in a unit that we have here on digitalization strategy and IT solutions. And we are actually helping the policy units from different domains to develop digital by design policies. So in this sense, under this kind of remit, we are also supporting the ESPR team here in Environment on the Digital Product Passport. ESPR standing for Eco Design for Sustainable Products Regulation. A few things on the regulatory and operational front of the DPP. First of all, most likely you're aware that the DPP registry status is advancing. So we had a public consultation on the DPP registry on the Implementing Act, and we are very, very close to finalizing the text under the guidance of DG GROW. And recently, JRC, the scientific arm of the Commission, has published or released, if you like, two key reports. The first was a few months ago on a methodology for selecting data points for the Digital Product Passport across the board, across all the product streams. And quite recently, a few weeks ago, actually last week, they also released one report on the data point specifically for textile products. And actually, I would like to, saying that, focus a little bit and set the spotlight on a specific thing that comes out from that report, that often the DPP's conception is that it concerns only the upstream part of the value chain, which is true. DPP is about collecting a lot of information on the product that relate to the upstream part. However, some of the data points relate to the reverse value chain, so the post-consumption reverse value chain. And one of them is the whatever has to do with recycled content. And recycled content is difficult to verify. You cannot really tell a material, a fiber, let's say, if it is a virgin or recycled just by looking at it. So you need data trails and transparency and traceability from that part, because otherwise there's a huge risk of greenwashing. And there has been cases in the press recently for the case of plastics where specific stocks of PET were actually were marked as recycled while it have been virgin ones. And of course, the regulatory risk there is very high. As regulations push harder for mandatory recycled content, then the incentive for greenwashing is higher, and it can be detrimental for the whole, let's say, circular economy business and business model. But again, focusing on the reverse part of the value chain, the drivers for data is not only just from such data points, but it's also from other sources like producer responsibility organizations. So these are mandated to manage waste, so always on the reverse part, post-consumption. So they need data to process on the received volumes, the feedstocks coming from the reverse actors like sorters, recyclers, and so on, in order to be able to make payments and balance the EPR economics. At the same time, policymakers, we also want information and data from the reverse part of the value chains to make informed circular economy decisions. And investors who, let's say, they want to invest on recycling facilities and so forth, they also want data on the different volumes in the reverse part. So actually aware of that, we are doing here in my unit a specific study on the matter, which covers many things, but two of the things that we're looking at is to what extent, what is the level of transparency that we can achieve now from the reverse part of the value chain. And we're exploring two specific links, whether they're missing. The one is, do we have the harmonized operational standards for all kinds of data and how we need to collect them, for instance, for the recycled content verification, for the EPR economics and so forth? Do we know what data we need? Do we have the operational standards to collect them? And secondly, assuming that we do have harmonized standards, then do we have the digital protocols, digital transparency protocols to collect this information? And we are in the process of concluding this report. And if you're interested, please feel free to connect and reach out on the matter. So thank you very much again for the invitation. That was quite a short and hopefully sweet introduction for me. And Luke, I hand over back to you for and staying in listening mode for the rest of the presentations. Thanks.
Thank you, Sotirios. It was a great introduction to some of the challenges that I think we also as projects tried to tackle in this in the time since the project started. In the case of Even Closer in the last year. Moving forward, I would go to Even Closer, but before that, I wanted to make I want to share an additional information which I didn't share, and it's a bit technical, so I will have to specify it. Even Closer is a I3 project, which means the TRL level, the technology readiness level, is 7 to 9. So the solution that we will see is a bit more mature than what is usually expected in an horizon. At the same time, because of that, the innovation could be a bit smaller, of course, than a project like an horizon that can have lower TRL. So first we go to what's nearer to the market in terms of funding program at least, and then we will go to two horizon projects. With that precision being made, I will call on stage Matteo and Andrea Dintino to present the Even Closer solution for traceability of critical raw materials. Hi Matteo and Andrea.
Hello, Luca. Thank you for hosting us. Hello, everyone. I'm Matteo from Forkbomb, and today I'm going to show you Attesta, our end-to-end stream and traceability platform for managing process evidence among organizations. The basic idea behind Attesta is fairly simple. It divides real process, or called streams, into steps that are bind to an organization, and subsets that are bind to roles in that organization. The final goal, as we said, is traceability. So at the end of a process instance, Attesta generate a public digital product passport exposed using a GS1 digital product link. So, as you can see from the home page of Attesta, that is where we are right now, it is not built. We can see that it is not built around few hard-coded streams, but it's built to be flexible around streams. Organization admins can create new streams from scratch, for example, using this Create a New Stream button, or using already existing streams as a starting point. For example, for this demo, we will take this gallium stream. We clone it so that we have all the information about that stream. Maybe I can improve it. Okay. Starting from the top bar, we the stream name. In this case, I can rename it as demo loops. And here we see all the steps inside the stream. In each step, we have substep. And as I said before, each step is bound to an organization that exists in Attesta. In this case, I want to change this. I will use organization one, since is our DIM organization that is the one that I'm logged in now as a user. Here we have the title of the step, and then we have the sub-step inside this step that are assigned to organization one. As we said before, each sub-step is bound to one or more roles inside the organization. So also here, we're going to choose, for example, that this sub-step can be completed by a chemical analyst of the organization one or a machine operator of the organization one. At the end, we have the most important things, that is the form of the sub-step, that is what the user will need to fill to create the digital product passport at the end. In this case, since they are not hard-coded, we can easily edit them on from our platform. On the left side, you will see all the available fields that can be used to build a form or to modify it. On its right side, you can see the form structure. On the right side of it, you will see the settings of a singular field in the form. And finally, on the right side, you will see the form preview. So for example, here, let's see, we have weight, that in this case at the moment is a string field. As you can see, I can use letters in it. So maybe it's something that we do not want. So we want to use a number input field, and we're going to name it weight. We're going to delete the old one. So here now, for example, you can see we cannot, I'm typing some letters, but we cannot, they're not inserted. We can only use number. More than that, for each field, we have some customization. For example, the descriptions, like, for example, let's say that in this case, weight is on tons. Moreover, it's a lot powerful. For example, let's see, time of collection. Let's rename it to date of collection. Not only that, we can have a date picker. So at the end, in our form, the date of collection will be a real date picker, more easy to use. And we can not only modify the form in here, we can also modify the step and sub-step. For example, the title, we can remove a sub-step, we can add new step. So we can create anything we want, anything we need to trace our product. So for example, here I changed this. So let's save it. So press here and then press the save button on top right corner and go back to the Attesta homepage. Here, let's go back to the normal zoom. Here you will see that the stream that we just created has appeared in the homepage. Let's open it. Here we see the stream instances. One stream can have obviously multiple instances, since each stream can be, for example, bind to a particular batch. So each batch will have an instance for it. And here we divided it in 4 categories that are available, that are the stream instance that need our input, so the logged in user input. Active, that are ongoing streams instances that need someone else input, not ours. Done are stream instances that have been completed, and so a DPP has been created for them. And finally, we have terminated stream instances that are stream that have prematurely ended. On the top right, we have the view preview, so we can have an idea of what this stream is asking to the user. For example, here we can see that it has 6 steps, as we already saw before in the stream builder page. And the first one is, as we modified it, is bind to the organization one. And it has only one substep that you can see here is date of collection and weight with tons. So everything is as we expected. Now we can create a new instance of the stream. We can give it a instance name, since instance can take a month to be completed. Having a name for it is help a lot to identify them. So, for example, let's call it demo instance. Let's start. And now, as you can see, we are moved to the form page. As you can see, since I'm in the organization one and I have one of these two roles, chemical analyst or machine operator, I am able to modify, to fill this form. As you can see, other substep after it are locked because I'm not in the organization that need to perform this substep, and moreover, until I do not finish this substep, no one can continue the stream. So it's blocked by organization, roles, and timeline. Here, for example, I will show you that I can complete this one, batch 1, 2, 3, 4, 5, 6, 7, 8. Date of collection, put it today. Device model, let's just put AA. Quantities, 100. Waste code, 1, 2, 3. Weight in tons, 22. We can choose also upload some waste information record, some files. Waste information record, all waste collected, and then we press submit. At this point, you can see that we completed the stream. All our data is recorded here. Moreover, on now the second step has become active, but since I'm in the organization one and not in Do-It-To-Lab, I cannot complete this sub-step. Another feature that we add to stream that we think is interesting, let's create another instance 2, is that the user that is able to submit, to fill a form, can also edit it, since we think that stream instances can change between one instance and the other. So the stream does not have to always be the same. So local changes can be done inside the instances. For example, let's say that we do not want the device model. We do not have the quantities, and we do not have this. So we change the form required in this instance, only in this instance, not in all the stream, but just in this instance. We had a reason why we changed this. For example, data not available. When we press save, we will see that now the form is changed. We change it for the data that we have. And moreover, this change is tracked also at the end in the DPP page. Other than that, the last thing that I want to show you is basically what happened when we end a stream. So the real reason we are here, the DPP, the digital product passport. In this case, I will take this stream that is a demo one. So the data written here is just something that we wrote to test the application. For example, this stream, as you can see, has 3 steps with multiple substeps. And here we have the view DPP data. When I click on this, public page will pop up where we have the stream title, the stream description. This is a GS1 digital link. And moreover, we have all the steps and substeps. So all the data inserted by the user are here. And finally, to ensure the digital product passport integrity, we have we used a Merkle tree So we create the hash of each single subset and then combine them to have a final Merkle root code that is an hash that can verify all the integrity of the data that you see in the digital product passport. If you want, I can share maybe this link since it's a public page. I don't know, maybe in the comments section or in the chat. I do not know. Yeah, this is basically the use of Attesta for digital product passport from an organization point of view.
Thank you very much, Matteo, for this in-depth presentation of the technical solution. Maybe one, since we are in presence of the commission, I see that the disclaimer was used, the logo of Closer and Closer as well as the UCO funded logo was there, and we will make sure that it will be there in the final solution. It's an important remark, but I'm very happy to see that the technical functionalities and that the real application is up and working, and I hope it was of value for the audience. Now, taking a step back in terms of technology readiness, I would move to the Horizon projects. We'll move to Mr. Volker Krumpel from MySpider to hear from both Apollo and Return projects. Hi, Volker.
Hi, nice to meet you. Yeah, let me first check how to share my screen here, or the presentation that I prepared. I hope you can see something now.
Yes, we can.
Yeah, I'm from MindSpider, as mentioned. And what we did is we started 2018 with a traceability platform that is also building on blockchain to make sure that data cannot be manipulated, or that it can be seen when things have been changed, manipulated, or otherwise used, modified. We started quite early with large companies, including Google, Volkswagen, and others, and we learned a lot from that. We started to track critical raw materials. For example, in the automotive industry, it was lead where we started with. But in the recent years, we also, of course, followed the EU regulations, in particular on the battery regulation, which requires now to have digital battery passports implemented in February next year. Also, we, of course, follow up on the Eco-Design for Sustainable Products regulation. Our platform is very flexible, can be adopted to any kind of market or product or supply chain. What we also, in the two projects that I will later present in more detail, did is we, besides EV batteries, we focused on PV industry, photovoltaics, and on electronics. In this project, it's mainly focusing on PCB boards. But as I said, we are covering the full life cycle of products, from mining raw materials, primary raw materials, up to the processing and bringing into market new products, to the recycling, reuse, repair phase, and so on. So we have various customers in these different verticals already, and what you see is already live. So we have this platform operating. Companies can generate passports. It's used already in the battery industry, in the automotive industry, but also in other industries. In this case, you will see battery passports. It's a bit more advanced, in particular in terms of also including dynamic data. That means live data from the battery that is in operation, about the state of health and state of charge and use or charging cycles and so on. But also digital product passports in other industries that may not include dynamic data, but if needed, this can also be implemented anytime. Because we expect, like the European Commission also indicated already, that this will grow into all kinds of industries. When we, what you can see here is a screenshot from the dashboard. So you see product passports, battery passports, you see certain dynamic fields that we can track. This is just a one example. In the end, we are very flexible to adopt this dashboard to your needs, to the needs of the customers. You see that it can become quite complex depending on the type of product and the supply chain you are in. This is just an example of one product passport, one battery passport. So you see the QR code. This QR code is generated with our platform, and then the companies print or stick these or laser into a product the specific QR code. So we have deep integration into production systems if this is needed or wanted by the customers. This leads to a little bit of complexity because you need unique identifiers, and you need to be able to do that or to generate them in the production phase. For example, a unique identifier for a battery needs to be defined at the production phase, and then it needs to be integrated into our system and then later be referred to or referenced to in the European registry for DPPs, which then requires that people can get linked, or when they click on something, that they get linked to the passport and see the respective data when they are authorized to see something. This also means that we have different access layers and different layers of visibility of the data, which all has to be assigned according to the data concepts developed either by the lawmakers, so by the regulation itself, or when the European Commission is mandated by the Commission. But mainly in the end, it's later about industrial standards that develop over time and are also always under development, where we have to follow up on that to make sure that people collect the data that the industry expects, that people share the data according to the rules that the industry set for their specific vertical or type of product, or that the lawmakers expect, for example. So you see, it can be a lot of information. What you see here on the screenshot now is a little screen, is just one section of that, some symbols that you can see, but you may see a lot of tabs here. We are flexible to add more on them depending on the regulation or the standard that we want to meet. You see also here, I'm not sure if you can see when I put my mouse on something, but here's a little icon that brings you to something which is an agent, AI-based agent that helps you to create passports, to ask questions, to find specific information, to import data, so to help people use the platform and make it easier for them to work with it. What you also have to understand is that we are talking about a lot of data. So it's usually not done manually anymore. Nobody wants to open manually a few PDFs to see for some information, or to look for some information. Sometimes you may do that and want to do that, but in general, this will be, or we expect this to be automated more or less completely. So data has to be machine readable, it has to be structured and standardized, and this is a key element of the work that we do. We are in close contact with the European Commission, but also with standard setters and industry organizations and so on, and of course with companies directly, to see what is feasible to do, what is doable in general, to understand what is the expectation of the lawmakers, what is the expectation of the compliance environment, but also of the practical expectations in the industry. This is just an example of a typical supply chain, a life cycle of a product. So you start with primary raw materials, and then it goes into production of a component of a full product, and this is placed on the market. It's used, and later it's repaired, reused, recycled, whatever it is. So there are different phases. And what you see here is that in the end, it's about linking or following up the information along the supply chain. In our case, we do that by linking different passports that are generated in the full process, so that people can see where raw materials, for example, came from. So each little box that you see here is represented by a passport, or can be represented by a passport. So, for example, you start with a batch of raw materials sourced somewhere. Then you have a passport for the specific raw material. This may be according to industry standards, or because there may be a regulation. And then it's shipped to somewhere and processed, refined, or whatever. And for each step, you can either update the passport or generate new ones and link them along the full supply chain until you end in the final product, or maybe later in the use cases for reuse, repair, or whatever. In batteries, for example, this can be a use case like this is what we do already. We see that a battery has been produced for an EV car, for example. Then in a repair station, the car is dismantled, the battery is taken out, then the battery itself is dismantled. We do this, for example, with robots who then read our QR codes, then understand better how to in a fast way, dismantle the battery, then take out, for example, certain battery modules, which are then refurbished or recycled or whatever the use case for a specific module or cell of the battery, then build a new battery of that, which then is put into a new use case, for example, in an energy battery storage system or something like that. There are different ways to show this flow of material. In the end is our main focus on making this all easy for the users, because it sounds simple, but it's complex. There are lots of questions, especially when we see that now, a few months before the regulation really kicks in for the batteries, there are still lots of questions. We now get several publications from the Joint Research Center who indicates how they expect or suggest to file data, to collect data, and to process data. And we then digest this, we analyze this, we check this with our customers and with industry organizations and so on, and then suggest a way how to do it. And then it's tested by users, by the industry already live in their daily business, which gives then feedbacks, which is really helpful for us. For example, what we understood is that many companies work with within their organizations, they have teams who want to work on things. So we don't expect that people fill in all the data on our platform manually. What we expected at the beginning is that everyone will use our API. So we have an automated access level that can push and pull data. But we see that most companies, at least in this first phase where everything is new to everyone, people like to work with Excel files, which they process within their own environments for data security reasons and for all kinds of reasons, for example. So what we did is we designed data sets and templates for them, which they can download. Then they can work on these within their organization and then later upload or we pick them up, these data packages, and integrate the data into the passports as needed on batch level, on individual product level, or on whole model or type level as you need. You can also dump these data points or data sets like Excel files or other type of information in our environment. Then an AI is trying to analyze everything and assign the different data points and content to the respective data fields, which then can be double checked so that people can follow up on that and check it and then approve it before the passports and the QR codes are generated, which then feed back into the industry so that the products are produced or the passports are stick or lasered into the products. Nevertheless, we think in future this all will be automated. There will be machines talking to machines, API talking to API, or pulling data or collecting data from where it's needed. So we expect that at the beginning, of course, when something is new, people will work on that manually, but later will be automated. Yeah, this is just a quick glimpse on key companies we work with. And this shall just indicate that we have also not only have the battery manufacturers or car manufacturers or big companies involved, but also recyclers and mining industry and different partners and associations and so on. Yeah, this is what I always have to show. I mean, we are involved in grant projects, which means it's European money involved, but also Swiss money and UK money. And this is now a marketplace that I would like to show you. This is the marketplace where that is backed by passports wherever passports are available. As you know, it's just starting. So there are not too many products who have already passports, especially in batteries. We see that. But you will later see that we analyze a lot of information, especially from other marketplaces and from other places where people trade things, to understand how fast is the life cycle of a product like a battery, for example. yeah, this is a marketplace. It's very simple, very straightforward. So you can understand where products are, the typical listings, and so on. You have some pictures and so on. What you see also here is a link to when there's a product has been placed on eBay, for example, there's a link to eBay with a little logo. Because we have a partnership with eBay, we can pull a lot of data from eBay and show it on our marketplace, because we wanted to have content that is interesting for people. We also analyze that. This is why we have this link to the market intelligence. And yeah, then you have all kinds of information about the respective battery or product. This is what you see here for batteries. We also do for PV in the Apollo project, and for electronic PCB boards in the Return project, which I will later show a little bit more on. Here also you see that this battery has a passport, so there's a link to the respective passport, which then includes all the information that you need to show according to the regulation. This is what I mentioned in terms of analytics. So we analyze how many cars of a specific EV type or model have been placed on the market by when. So let's say 10 years ago, a certain model, like for example, this Nissan Leaf has been produced and brought on the market in Germany in a certain number of cars. So then we try to understand, for example, you see some peaks here. This is because Germany had some subsidies that then run out, and then lots of people buy a few days beforehand, and then the peak goes down. But with these peaks, we later see this little dotted line, the red line. This shows an expected backflow of used cars or used EV batteries into the market for reuse, repair, or recycling. So it's a little bit flattened, and there are different assumptions that feed into that. We can modify that, but this already can give a rough understanding of what kind of models and products we expect in a few years from now. We also analyze what are the prices today for used batteries, for example, to understand what is the best price per kilowatt in different markets, like in Germany, Switzerland, France, Portugal, and others. So we have 10 markets that we are analyzing to get a good understanding. And for those people who want to later reuse or refurbish batteries, this can be very interesting information. What we see at the moment, that new products are quite cheap, like a new battery, it's pushed into the market to a very competitive price, so that reuse, repair, and recycling may not make sense. But it depends on the type of battery, the type of car, the type of economic environment, and so on. So things can change fast. And this is why we think this data can be really helpful. This is some more analytics. For example, you can compare different car models and then see the price per kilowatt of a used battery, depending on the age of the battery and depending on all kinds of information that feeds into that. This shall just indicate what people on the market usually consider anyway, and they may have some understanding of that because they are deeply involved in this business, but we want to make this data more available for those who need that. And also challenge it. We are exploring this and try to check out and understand what people are interested in. And we know that for batteries, this may be easier than for PV modules or for PCB boards. This is what I later will also show you. There's some complexity involved. Also, I wanted to show you that at the moment, you see 3 markets that we are addressing. So batteries, PV, and electronics. We can also, and we are exploring this with different players like DHL, to develop corporate marketplaces or vertical marketplaces for specific industries, which then can, when you have a listing, for example, of a used battery, you can show that, and maybe if you have, if you are authorized, you can place a battery on different marketplaces. For example, for let's say you have a Ford battery, you want to maybe show it only on a Ford marketplace for Ford customers. But maybe you want to show that also in the electronics marketplace or in other relevant marketplaces. And we think that building small communities around specific marketplaces or even brands can make sense. We have to check that. We are not sure if this works, but this is something that is highly interesting at the moment, especially when you bring AI and AI agents into play. We also see, as I indicated, there will be different types of passports for different industries, and we have our environment enables us to integrate all kinds of formats and templates for passports. You can generate battery passports or product passports on the marketplace, which are then feeding into the MindSpider platform for passports, or you can link to them as you like. And we expect that we are not the only one. I mean, there are hundreds of platforms where you can generate passports. So you can always link to other marketplaces or other passports or other environments that have information about passports to be quite flexible. Yeah, this is just a quick example of how this works, no? When you fill in these fields. As I said, we expect that in future this will all be automated, and in the end, at the moment, in the next years, we expect, or in the next month, and maybe in 2027 and 28, we expect that for specific markets and specific products, there will be a need to design all these templates, to digest all this, to develop the processes to it for this, like we do, for example, in the Apollo project for the PV industry. So our task, our MindSpider's task, is that we manage all the data, distill all the relevant information that people expect to be relevant for them. For example, someone who's placing a product on the market and who wants to market it has different informational needs or wants to share different information than, for example, a recycler who a few years later will see this product maybe on his yard. But yeah, that's a different time, right? That's 10 years from now or even later. In PV, it can be 30 years from now. So there is a big difference of informational needs and interests. And this is what we try to understand and digest and then develop into products that make sense. Yeah, this is just a screenshot of the website. As I said, this is focusing on PV. So what's interesting is that, or what we try to do is not to be only relevant for those who place products on the market and generate first product passports, but also we want to have services that are related to the respective products represented on the marketplace. For example, companies for logistics, recyclers, testing companies, or experts who reuse these kind of products, refurbish them, and so on. So it's not only about product offerings, but also about service offerings, and of course, service requests and product requests. This is all an early phase, so there are not too many companies on the platform yet. We want to grow. So whenever you know someone who may be interested in putting their listing or their offerings or service requests or whatever on our platform, these are highly welcome. We now also have to make sure that we manage everything properly for the different industries. So it's not always easy to really get deep into an industry. What we see here is, for example, product offerings can look very different. This is what we also see on eBay, for example, how product offerings are described. There are various ways how people do that. Depends on the country where they're in, the different use cases people are working in. And this leads to a little bit of complexity. Because sometimes you have a lot of information associated with a listing, like a detailed description of a product, but sometimes people just refer to images. They make some photos of the product, and then they upload them on eBay, and then they say, all the information is in the photos, which from a machine readable point of view, it's hard, because you have to really then analyze the images. And this is what we started doing. So we analyzed 100,000 of images, digested the information, categorized it, and then tested it and fed that into data templates and so on. This is also in the Return project, which is about these PCB boards. So it's electronic waste from computers. It's quite interesting because you see that depending on when a PCB has been produced and for what, there can be different percentages of gold or other precious metals in it. Different types of plastics may have been used. And so it really depends on what you have in front of you. But the models and the types of PCBs, they change all the time. So it's not such a small market of producers like in the automotive industry. It's really a lot of different bigger and smaller PCB manufacturers. Also, from a recycling perspective, usually this is all shredded and then smelted, and then or there are different ways of then sorting and separating the different components or ingredients, which really make it complex. And in this return project, we try to really understand how to get a high efficiency in the recycling and separation of these and extracting of the respective raw materials from these PCB boards. In Apollo, it's the same. We also try to understand how to separate things that are glued together in a high efficient way, and then understand, okay, what kind of raw materials are in that, so that it's really commercial feasible to do this, all kinds of handlings that you need. So it's costly, the more manual process you have involved, or the more energy you need to separate things. So this is a major step to really understand what is the best practice there to do the separation, to do the sorting, to do the collection of the materials, and then bring that into a market that can, make the best out of that. Here are again some screenshots of different elements. Again, service offerings are really welcome here. For example, if there are experts in separating, in collecting, in sorting, in dismantling things, this is what the industry needs now. It was not so much in the focus in the past. And we also see that there are, of course, shredding is something that is very popular, very efficient, and very established in the industry. But there are still different ways how you can do things, also different efforts you can put in shredding things. But you may lose also a lot of value when you shred things. So, for example, testing components and then checking if they can be reused. And that before you start threading or thinking about threading, this is a key element of all this, because keeping something in the market as long as possible before it gets shredded is, I think, a key element of becoming more efficient, using less energy, have a higher value in the product. This is just a screenshot of different types of PCBs. I mean, you see on a first glance, things may look simple and straightforward, but the devil is in the detail. For example, there are so many different variations of things that are plugged into a plastic board with metal in it. There are all kinds of different items on it, which have different values depending on when they have been produced. And for example, the difference in gold included in these PCB boards can vary a lot. And then understanding what is in front of you can make a big difference. So imagine you have a container full of PCB boards of all kinds of history. You need to understand what is in front of you. So we start with image recognition. You have to have these separated on the conveyor belt. We managed in this project a high degree of speed already. So for example, 1 meter per second, these cameras can digest. This image is not of these cameras. This is something that others in this project do. But if you want to understand what is in front of you, speed is very important. And this is a critical thing. Also the cost for that. To analyze information, then we have 3D scans. We have all kinds of analytics with images and lasers involved, for example, sometimes to understand what is in front of you and what is the chemical composition and how to best process it or sort it and then process it. But this has to be done fast, because if it's not done fast and commercially in a feasible way, then usually just shredding what is in front of you, usually it's done the way, or that's the way it's done today, right? Without a lot of different separations of these boards, for example. The same with TV panels. I mean, they rip off the aluminium, and then there's a glass a lot, but the rest, because it's, I mean, there is some silver in it and other components that are interesting, but to separate them out is a cost-expensive process. So it's not easy to do that. And to support this, we need to have more efficient practices in sorting, separating, and refining the respective raw materials. So this was a quite fast run to the different projects. I hope I was in time, Luca.
Yes, absolutely. Super interesting as well.
Yeah, I hope you could follow me. Sometimes I read quite fast, or I speak quite fast, but yeah, now it's time for questions. So whoever has a question.
I will call Matteo also on stage back. And maybe one thing to begin with, I think we hear two different digital product passport systems, also with two different business models, if I understood well, because I saw clients of mine Spider already active, while Forkbomb, I think we don't have clients, but it's an open source business model. So, but for both of you, one question from my side will be, how what's the main challenge to scale up these solutions? Because they're not mainstream yet, definitely. Regulation is coming, but bottom up, what is the main challenge to scale up the adoption of these solutions?
Matteo, do you want to start?
Yeah, I think that one critical aspect that is something that we have not done yet. We will try to. It's not. We will try. We will integrate it in the future. Is as also Volker already said, is the automation. I mean, user does not have to write the data down by hand. Something that we want to add in our software is speaking directly with IoT devices, so that industries can already collect the data directly from the machine to the platform, and so the DPP is populated in an automatic way. And I think that is one of the main problem with the adoption right now, is that if the user have to insert data by hand, most probably it will not. That's the reality, I think.
That makes sense. So making it easier to apply technologically wise, like the technology just to be as user friendly as possible. Volker, what's your opinion on that?
Yeah. So first of all, people like to stick to what they know. If you want them to change, it's really hard. If there's an advantage for them, they may pick it up. But if they're not sure what the advantage is, or if the advantage is too far away in the future, then this is quite human, right? People want to do as they know, where they're sure and where they know how to behave and what to do. So, of course, it's really helpful that we now have this regulation in place with all kinds of, I think, really helpful frameworks. Also, what the Joint Research Center is doing is really amazing, I think, to understand all this, the different expectations, and then put that into data models. We also do that, and we talk a lot with these experts. But you have to do that from several fronts, right? And it's not only Europe. Europe is not playing the big role in the raw materials. We are involved in projects in the middle of nowhere in the bush, where people dig out some raw materials by hand out of the ground. And we have developed tools to make that, to do and to automate the data tracking from there. On the other hand, we have to do in the same projects with really large multi-billion-dollar companies who work in all kinds of in legal environments, like in different, not only in Europe, but also in China and in the US and in Canada and Brazil and wherever. So this is really complex. We saw in many projects that there are individual people who don't have time for anything but do their daily job, work in parallel to companies that have big teams to do all kinds of stuff, like compliance teams, other teams, and so on. Manage all this is hard. And we see with this regulation already, with the battery regulation, where we try to really get a lot of input for other projects that we then make use of the learnings. Although it's only a few months when this really kicks in hard, you may not be able to import to Europe when you don't have these passports at hand. That still a lot of companies are really slow because it takes time for them to adopt. They have a lot of questions. They see, maybe the regulations changes again. We have Omnibus, which changed already a lot. Maybe the legal environment changes, but also the political environment changes. No? A few years ago, sustainability was a big topic. Today, for cost reasons, many people are not so sure anymore if they put an effort on that. So that's what makes it hard, I think. Sorry for a long answer, but it's what we experience.
Yeah. Maybe because I see also we don't have much time left, but before asking you a couple of other questions, I wanted to ask two of you if you had questions for each other, because you saw two different presentations of work you were not familiar with before, I assume. So maybe you have some question for one Matteo for Volker and Volker for Matteo, basically.
I have a really small question, but something that I'm asking myself. Basically, as if I understand well, in your marketplace, you have the possibility to add the DPP, but it's not mandatory, right?
Exactly.
My question is, in this moment, I don't know how much advanced is this, but in this moment, is the DPP an advantage on that? Do you see the DPP as an advantage on that marketplace? I mean, the materials that have a DPP along with them are chosen more frequently. I don't know. I don't know if I explain myself in the right way.
No, I know what you mean. And to be very frank and straightforward, not at all. At this stage, it's mainly pain for companies to develop a passport.
Yeah.
They think, why should I do that? They buy my batteries anyway. Or even if I have a passport, I don't sell more. Nevertheless, this may change fast. What we see also is that there's a gap between, I mean, you may really use this information and find it very interesting when you recycle something to understand what is the chemical composition of something. When you produce something new, you just want to sell it on the market and you don't think about the future. Although you have these responsibilities by law, and this is not new, this is quite old already, very established. So there are recycling loops and so on already established in the automotive industries. They work more or less good. But in the end, everyone is just focusing on the next things very close to them, like selling a product or collecting a product or recycling a product, and they don't think along the full life cycle. We hope that this will change, and I think it will change the fastest. The earlier you understand, oh, there's a higher value I can get because I have this information. I really understand this is what you have in front of you is real. And in particular, the access to the dynamic data for a battery is highly relevant here, I think. Especially when you can automate that. I'm not sure how this will be, for example, with textiles. Textiles is a very low-cost thing compared to a battery that costs 10K. Nevertheless, I mean, I think thresholds for recycled content can also change a lot. Recycling efficiencies can change a lot. Even if it's not competitive to a new product, but if it's mandatory by law that you have to have a certain volume of recycled content, this can also change a lot. There may be different understandings of this in different countries, but I think you just have to start and explore that. It's a bet at this stage, I think. We don't know where this ends, but what we know is that we don't have enough raw materials in a high value in our market, in Europe at least. And this is why I think it makes absolute sense to push that front and to have really know-how on to reuse, repair, recycle, and manage all this also in data fronts and so on. Make use of AI the best ways in a practical way. And this is going far beyond developing LLM models, what Americans and Chinese are really good at. But doing things on a practical level in a day-to-day business, this is where we can be really good at. And I think this is also a market advantage for Europe.
I think probably also between the relationship from outside to import products to Europe will have an impact. But
yeah, what is interesting, we get a lot of requests from China more than from Europe, at least in the battery sector, right? Because there are Chinese batteries who want to get into the market in Europe, whatever it takes. But nevertheless, I'm wondering what from DG Environment, what they think about what I just mentioned or what we just mentioned. Is this something of interest, or do they see advantages in this?
I think Sotirius left the call, but he did tell me that we shared the contacts emails with him, and he does want to follow up on this. So I do expect that. But there is a strong interest from the environment in what we are doing. Of course, if you link it up to what they are looking at, more on the data points and what the system that enable. But basically, we are speaking about making it mandatory. But how do we make it mandatory? That's a bit what we are looking more into it for the way I understood it. But the and maybe since we are at the end of the hour, but one last question for Matteo from my side, and also with a comment of you, Walker, because you have mentioned several times the different standards and also how volatile it can be, how it can change from one day to the other, what kind of standards you're going to follow up at the end for the DPP. At the same time, Matteo, if I understood well, you guys decided to go with GS1 standards at some point, where we do everything GS1 compliant, and then if there will be any, we'll see later on. Why the choose of GS1? And Volker, did you have an internal discussion about the standards, and what kind of standards were you? Did you decide to go to? If you decide to go to any?
We decided about GS1 since, in our opinion, is one of the main leader in this sector. So we choose to follow the GS1 digital link for this reason, and for the moment we are following up with the documentation to see if also any standard about the content of the DPP, I mean about the following the update of the standard about the content of the DPP. In this case, for the moment, our implementation is proof of work, proof of technology. So it does not follow strictly the data that has to be in the DPP, but it's something that we are following up. I mean, it's something that I think that if we do it today, tomorrow it will change. So we are focusing on, for example, automatize the introduction of data into the form, and also a lot on the user interface and user experience from now on, since, as you see, the platform is not really beautiful from a user perspective, but it's something that my colleague are redesigning and starting to re-implement it in these days. So in the next days, next weeks, you will see a better looking platform. So for the moment, we are leaving it aside, waiting for a real standard, I mean a final standard to come out and to update it in the at the end.
So the standard in URL, but still for the data models of DPP, is not possible, even following just one standard, to have something final yet, of course.
Yeah.
Thank you. Volker, very briefly, we are out of time, but it was a very interesting conversation. What about you? What was the internal discussion on standards for you guys?
Yeah, first of all, we think that everything changes permanently. So a standard is not set in stone. It also, standards are made to be adopted, right? There are industry people talking to each other, and then they change the standard when it's needed. The same with laws and regulations and with industry practices. So we will always change and adopt to that. And this is why we try to build our platform in a way that it's really adaptive to any environment, any legal environment. We are operating in China as well as in Europe and the US and in other areas of the world with different legal frameworks, with different industry standards and practices and so on. So we have to be flexible on that. What I also expect is that the role of human beings in this will become less important. So Matteo, I think you really did a great job. And so if it's not nice yet, I mean, it has to be practical. That's more important for most users. And it has to be machine readable. Because we expect, and I think everyone does that, machines will be the ones who later digest information and then suggest next steps, and then humans will decide or will be involved in decision loops. But opening a PDF to read 100 pages of something, of a report or whatever, I don't expect that many people will do that. They may not even be aware of what is confidential and what not, and this you can automate, right? So yeah, I think this is a key element of our work.
And with these words, I thank you both for the time today. So I hope the audience had a good understanding of the state of the art of both the challenges at European level as well as the solutions being developed by the community working on the topic. And I close here the Loops episode and see you at the next episode. Thank you. Bye-bye.
Thank you, too.
Thank you,
Bye-bye.
Luca.